Today we're going to talk about properties of exponents, the quotient property. Notice what happens when you divide powers with the same base. I have 4 to the power of 7. 4 is the base, 7 is the exponent. I have 4 to the power of 2. 4 is the base, 2 is the exponent. That 7 means I have 7 fours on top. The 2 means I have 2 4s on the bottom. Now, if you remember from simple math, is if you have the exact same thing on top as you do on the bottom, separated by multiplication, they cancel out because 4 divided by 4 is the same as 1. And then I have another pair. So now I have nothing left on the bottom. How I look at this is I have 4 on top, I have 4 on the bottom. I have 7 4s on top, I have 2 on the bottom. Where do I have more? Well, I have 5 more 4s on top. Therefore, that's my answer. I have 5 more 4s on top than the bottom. I have 5 A's and I have 3 A's. Where do I have more A's? I have more A's on top. How many more? 2 more. Well, let's look at it in an expanded version. 5 A's on top, 3 on bottom. I can cancel them out 1 to 1. And just like we said, I have 2 more A's on top. To divide powers having the same base, subtract the exponents. That is the official rule. However, I like to look, where do I have more of a particular base, and then go from there. Simplify the expression. All right, so right now I have 8 to the power of 10 over 8 to the power of 4. Well, where do I have more 8s? I have 6 more on top. I have negative 3 to the power of 9 on top, negative 3 to the power of 3 on the bottom. Where do I have more? I have more on top. I have 6 more on top, or using the rule, 9 minus 3. All right, I have r to the 7th on top and r to the 6th on bottom. Where do I have more? I have 1 more r on top, so my answer would be r to the power of 1. Remember, if you don't see a 1 there, it is understood to be 1. 1 and y to the 5th, 1 over y to the 5th times y to the 8th. This y to the 8th is like having it on top. When you don't see something below it, it's understood to be 1 below. So I have 8 y's on the top, I have 5 on the bottom, I have y to the 3rd left on top. That means I have 3 more on top. All right, look what happens when you raise a quotient to a power. All right, 3 divided by 2 is a quotient. 7 is the power. A over B is the quotient. 4 is the power. That means I have 7 3 over 2's. 7 of them. I can't cancel anything out because these are different numbers. So it's 3 to the 7th, 2 to the 7th. Same thing with A and B. 4 means I have 4 of these. So 1, 2, 3, 4. I can't cancel anything out, so it remains. These examples use the power of a quotient property. What you do is you distribute that exponent to both the numerator and the denominator. So this 2 is going to go to that 7 and that x. But notice in that one, there's a negative in front. Negative squared is positive. So 7 squared is 49. And then distribute that square to the x as well. Next problem, the little 2 on the outside goes to x squared, so that would be x to the power of 4, the little 2 goes to the 4, so that would be 4 squared, and the little 2 also goes to the y. So x to the power of 4, 4 squared is 16, and then y squared. Now the last example here, notice the negative again. Negative to the power of 3 keeps a negative, because a negative times a negative times a negative brings us back to negative. You take that 3 and you bring it to 5, and 3 to this 3 and you multiply. 5 to the power of 3 is 125. And remember, we keep that negative. Y to the power of 3 means there's 3 sets of these, so 9, and you multiply. All right, let's see what you can do. Pause for a minute. So remember, the 3 goes to the 4, and the 3 goes to the 2. The 3 goes to the 5, and the 3 goes to the y. 4 to the power of 3 is 64. 5 to the power of 3 is 125. And I can't simplify here because I have different bases. Same thing here. Remember to take the exponent all the way to the first base as well. That's where people make the mistake. All right, this one's a little bit more complicated. This 5 is only on this, so we take care of that first. 5 to the 10th and 5 to the 5th. I carry this with, and now I have a problem where I am multiplying. All right, so I look, I have A. I have 10 A's on top. I have 2 on the bottom. Where do I have more? Well, I have 8 more on top. I can't simplify 1 and 2, and I don't have any other B's. So first they combine them, wrote them in one fraction, and now simplify. All right, 7 goes to the 3 and 7 goes to the y, which is power of 1. X to the 21st, y to the 7th. Now we're multiplying. Let's bring it all together in one fraction. I don't have any way to simplify a 1 over 3. Remember, it's understood a 1 is here. But I look, I have x on top and bottom. Where do I have more x's? I have more on top. And y is only on the bottom, so I leave it alone. All right, that would be it for today.